Guys, is screen visible?
ಅಲ್ಲ ಮ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ ನಾನು ಮ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ ಶಬ್ದ ಕೇಳಿಸ್ತಿಲ್ಲ ಮ್ಯೂಟ್ ಮಾಡಿ ತೆಗೆದಿದ್ದೀರಾ
Guys, is the screen visible?
Yes, sir.
Yes, sir.
Am I audible?
Yes, sir.
Yes, sir.
Okay. Then we can start the class. See, morning I discussed about some 3-4 problems. So we will continue with that. This is another type of problem. You can observe this. Find the reactions at the ends if the diameter of the bar is 25 mm. Find also the stresses and deformations in each portion of the bar. E value is given. Okay. So if you observe this bar, you can see that this bar is restrained at these two ends. This end and this end, it is restrained. Restrained means it is fixed. There is no change in deformation. That is the meaning. That means the total deformation of the bar, dl or delta L, whatever you take, it will be 0. dl is 0 here. Why dl is 0? Because this bar cannot elongate. It neither elongates nor contracts. So delta L will be equal to 0. So this is the first portion, second portion, third portion of the bar. All the bars, they have got the same diameter. Okay, circular bar. But forces are given here. 30 kilonewton is acting like this at this junction. 60 kilonewton is acting like this at this junction. Okay. Now, since these two are restrained, so these two ends of the bar are restrained means this bar neither elongates nor contracts. That means your total deformation of the bar will be 0. So delta L is 0, but you can have some values of delta L1, delta L2, delta L3. Some of them may be positive, some of them are negative. So the total sum will be equal to 0. That is the meaning. So please understand that when they give restrained condition at these two ends, so total elongation will be 0. Okay. Now here he has given that the diameter of the bar throughout the bar it is 25 mm. Area of the bar will be pi d square by 4, which is 490.8 kilometer square. Since the ends are fixed, total elongation of the bar will be 0 here. So your delta L will be 0 here, but delta L1, delta L2, delta L3, they are not zeros. You will be having some value. So let us see how to find those three deformations here. So for that, we have to take the free body diagram of each segment separately. AB, BC, and CD, they are the segments here. First, we will take up this AB. So here in this problem, he has asked the reactions of these two ends. So since he has given the fixity like this, reaction will be in this direction. Hope you know how to write the reaction. So this reaction, I will take it as RA, and reaction at this end will be RD like this. So it's D. So RA will be P. I will take RA as P, and RD will be in terms of P. How to get that? So we have to apply that equilibrium equation for this. Sigma fx is equal to 0. If you apply this equilibrium equation, what happens? This P will be positive. I am taking forces acting in this direction as positive. So in the left direction, it becomes negative. So P is positive, 30 is positive, 60 is negative, RD is negative. So if you write that, so P plus 30 minus 60 minus RD is equal to 0. So if you write that, you will get RD as P minus 30. So all the values, it will be in kilonewtons because the forces are given in kilonewtons. So RD will be, this reaction is P, this reaction will be P minus 30. So once you get the value of P, you can write down the reactions at these two ends. Now, first one is this portion. When you take this portion, so delta L1 is the deformation here, delta L2 is the deformation here, delta L3 is the deformation here in this bond. So let us take the free body diagram separately. I will take this AB part. So on this AB part, you have P force like this now. P is this reaction. So naturally, to keep this in equilibrium, there should be a force in the opposite direction here at this end. I am separating all these three segments. So that means totally, completely, this portion is subjected to compressive force, compressive. So towards the bar is compressive. So compressive stress will develop in this portion AB. Next, coming to the last one. Last one, here we have seen that RD is equal to P minus 30. So there is a force of P minus 30 acting in this direction. So that is also compressive. Now to keep this in equilibrium, so you have to take a force in the other direction. So P minus 30, this is also P minus 30 in the other direction. That means completely, finally, this portion is also subjected to compressive force. So this is compressive force P, this is compressive force P minus 30. Now coming to the middle portion, so since I have taken a force P like this, I have taken a force P like this here, introduced force, we have to introduce another force here to keep the junction in equilibrium. So I have to take in the other direction. So P I have introduced it like this here. So for this bar, it will be in the other direction like this. And this 30 kilonewton is there as it is. 30 kilonewton is there. Then here P minus 30 is acting in this direction. So to keep it in equilibrium, the junction, so you have to take P minus 30 in the other direction also, opposite direction. Then the 60 is given here. That also we have to take. Now, what is the final force P acting on this? It will be 30 plus P. See here, both are acting in the same direction. 30 plus P. Here also it becomes 30 plus P. You just add this. 60 plus P minus 30 means it is 30 plus P. So 30 plus P is the compressive stress, compressive force acting on this. So this portion is subjected to a compressive force of P. This is subjected to a compressive force of 30 plus P. This is subjected to a compressive force of P minus 30. So once you get the value of P, then by substituting the value of P here, so you can get the actual force acting on this. So what we have done up to this is, since the ends of the bar are fixed here, total deformation of the bar will be 0. So the delta L will be 0. By using the equilibrium equation, sigma f x 0, P plus 30 minus 60 minus RD is equal to 0. So RD becomes P minus 30. So then I have taken these segments separately and I have written the free body diagram of the three segments separately. Now once you get this, we know this condition, delta L is equal to 0. That is delta L1, which is the deformation in this bar. Delta L2 is the deformation in this bar. Delta L3 is the deformation in this portion. You have to add them, that will be equal to 0. Now one by one, let us find out what is delta L1. PL by AE is the formula because it is uniform bar. PL by AE. So what is the force acting on the first bar? So delta L1 is given by PL by AE for this one. So P is P itself into L is 275 mm. See here, length of this bar is 275 mm divided by area is 490.8. So area remains same for all the three portions. 490.8 into E value is 2 into 10 power 5 Newton per mm square. Please note that here the P value E will be in kilonewtons only because the forces given are in kilonewton. So this is your delta L1. Next delta L2 will be PL2. P2 L2 divided by A2 into E. So what is P2? P2 is the force acting on this. So it is something but P plus 30 or 30 plus P. So 30 plus P into length of the bar is 150 mm divided by area is same into E is also same. So here A and E are constants here. Plus next delta L3 is whatever force is acting on this portion, which is P minus 30 into 325 is the length of the bar, this portion 325 divided by area is same 490.8 into E value 2 into 10 power 5. So what I have done is I have used the formula PL by AE for all the three portions separately, and I have added and I have equated to 0. Now, by simplifying this, you can find out the value of P as 7 kilonewton. So, you are getting P value positive. See here, P is equal to, if you solve this equation, you will get P as 7 kilonewton. So, since P is positive, whatever direction we have assumed in the beginning, so P I have taken in this direction, it is correct. If you get negative value of P, this reaction will be in the opposite direction. That is the meaning. Here we have got positive value of P, therefore assumed direction of P is correct. So once that means at this end, reaction is P, that is 7 kilonewton, whereas at this direction, at this end, so the reaction will be P minus 30, that is RD is P minus 30. P is 7. So 7 minus 30 means minus 23 you will get. What do you mean by that minus 23? So minus 23 means RD I have assumed in this direction in the beginning, but I have got negative value. So RD will be in the opposite direction. See, I have written here. So initially we have assumed like this, but since we have got RD value negative, it acts in the opposite direction. So like this. So RD will be like this after calculating. I have written here after calculating. The direction changes like this. Now RA will be in this direction. RD also will be in this direction only. Initially we have assumed like this. After calculating the value of RD, we got it negative. Negative means it is in the opposite direction. So now we have got the values of the reactions. So RA is P, that is 7 kilonewton. RD is minus 23, or numerically it is 23. So this negative sign shows that it is in the other opposite direction, opposite to assumed direction. Now that is first part of the problem is over. Find the reactions is over. Next, find the stresses and deformations in each portion of the bar. Find the stresses and deformations means, see, deformation is given by delta L1, delta L2, delta L3. Okay, these are the deformations. After finding deformations, you can find out the stresses, or first you can find out the stress, then you can find the deformation. Anything is okay, they are independent. So delta L1 is the deformation in the first bar. So formula is PL by AE. So this is actually delta L1. Now we have got the value of P now. P is 7 kilonewton. Put the value of P here. So put the value of P in newtons, because this E value will be in Newton per mm square, length is in millimeters, area is in millimeter square, P should be in newtons. Please make a note of that. So delta L1 is this value. So put the value of P, because the compressive force acting on this first portion is P, which is 7 kilonewton. So put that as delta L1 is equal to, if you put in this is a simplified form. If you simplify this numerical, you will get 2.8 into 10 power minus 6. So P into that. So P is 7. So put the value of P as 7 into 10 power 3. So that step I have not written here. So this P is 7 into 10 power 3. Please make a note. 7 into 10 power 3. If you substitute and simplify, you will get this as the answer. So this is the deformation in the first portion in millimeter, which is negative. Why it is negative? Because it is compressive force. So since it is compressive force, there will be a contraction of the bar. There will be a contraction of the bar. So this is the, since it is compressive force, you are getting contraction of the bar. Now coming to delta L2, second part. So delta L2 is this. So here just you have to put the value of P, that's all. So P is 7 here. So 7 plus 30, 37. See, I have taken the same expression. So put the value of P as 7. 7 plus 30 into 10 power 3 we have to take, because it should be converted to newtons. So P is 37 into 10 power 3 into 150 by this value gives this value. So this is also negative. Why it is negative? This is also compressive force. So 37 kilonewton is the compressive force acting on the second portion. So delta L2 is negative. Now coming to the third portion, you have the force acting like, now what has happened here is this P minus 30 becomes minus 23 now. Minus 23 means it is subjected to a tensile force. So see, third portion is subject to tensile force. What is P minus 30 minus 23? But it is acting like this now. So this third portion is subjected to a force, tensile force of 23 kilonewton. So take the value as 23. So this becomes actually 7 minus 23 means it is uh, tensile, 23 tensile. So 23 into 10 power 3 into L is 325 divided by A into E gives this value. So this is positive, elongation. So here observe, please observe here that the first and second portions, they are subjected to contraction. Third portion is subjected to elongation. So because you just observe this diagram. So this is compressive, this is compressive. This becomes tensile because after calculation, this P minus 30 becomes minus 23. Minus 23 means it is in the opposite direction. This also will be in the opposite direction. So this becomes tensile. So tensile means there will be elongation of the bar. So that is why what happens, first portion is subjected to a contraction, second portion also contraction, but third portion elongation. So the total effect will be zero. So delta L1 is negative, delta L2 is negative, but delta L3 is positive. That means if you add these three, you should get zero. Please note that the check is like this. What is the check is minus point, this becomes negative, minus 0.0196 minus 0.056 plus 0.075 should be equal to 0. So the minus plus of this should be equal to 0. So when you get that as 0, then the total deformation becomes 0. Okay, so delta L1, delta L2, delta L3, if you add all the three, so you will be getting 0. You can check that. Next, finding the stresses in each bar. Stresses are given by force divided by the resistance force divided by area. So for the first portion, the force is 7 kilonewton, 7 into 10 power 3 divided by area. You have to take 490.8. So this is subjected to compressive stress. The first one is compressive stress. Second one is tensile stress. That is also compressive stress because the force is 37 here, 37 kilonewton. So 37 into 10 power 3 divided by area, compressive only. But whereas the third one, it is elongation. Elongation means tensile stress will develop. 23 kilonewton is the force on the third portion. So 23 into 10 cube divided by 490.8. So this is tensile. So this is very, very important type of problem. So understand it and do it. So then if they ask you to find strains also, epsilon 1, epsilon 2, epsilon 3, we can find out. How to find that strains? I have told you you can use in two ways. You can find out in two ways. One is strain is equal to stress divided by Young's modulus. That is, if you want epsilon 1 is the strain in the first portion. So it is compressive strain only, which is given by sigma 1 divided by E. So whatever value of sigma 1 for 14.262 you have got divided by E value 2 into 10 power 5 gives the strain in the first portion. Second portion strain is epsilon 2 is equal to sigma 2 divided by E. Third portion strain is epsilon 3 is equal to sigma 3 divided by E. So like that you can find out strains, or you can use another formula. Epsilon 1 is delta L1 divided by L1. So this is delta L1 divided by L1 is 325. Okay, sorry, 275. Next, epsilon 2 is delta L2 divided by L2. So second portion length you have to take. Epsilon 3 is delta L3 divided by L3. So only thing is the first two will be compressive strain, last one will be tensile strain. So this is how we have to do this problem. Very important type of problem. When they give fixity condition or restraint condition, or when they give a support condition like this at the two ends of the bar, your total elongation will be 0. So that concept, to understand that concept, this problem has been done. So the total deformation is 0, but individual segments of the bar may be elongated or contracted. So the summation will be 0. So naturally, some of the portions will be elongated, some of the portions will be contracted. In this problem, first two portions, these two are contracted, this is elongated, so that the net effect is 0. That is the meaning. Next problem is find the total elongation in the given system. So there are two bars here. The bars are hanging here. See, so self weight we are not considering here. So when the bars will be vertically suspended, it will have that self weight also. But we are not neglecting self weight here. Only applied force we are taking. See, in this there are two uniform bars connected here. So first one is this is 200 mm. This is also 200 mm. So both are 200 mm length. And diameter of the first bar is 20 mm. Diameter of the second bar is 10 mm. So there are two forces acting on this along the axis of the bar like this. 10 kilonewton is acting here, 20 kilonewton is acting here. Both are acting downwards. Now we have to find the total elongation of the in the system of the bars. So how to find total elongation? Once again, you can take this first portion as 1, second bar as 2. 1 and 2 are the portions. So let us find out what is the actual force acting on the bars individually. So once again, we have to write the free body diagram. So instead of giving horizontally, they have given vertically. That means this is fixed. This is fixed because it is hanging. Weight of the bar will be acting downwards. So forces are acting here. That is why it is fixed here. Now consider this second portion. In the second portion, 10 kilonewton force is acting downwards. Only second portion you take. Now, to balance this, there should be an upward force of 10 kilonewton. This is downward. To keep this in equilibrium, there should act an upward force of 10 kilonewton like this. That is for the second portion. For the first portion, what happens? Already this 10 kilonewton is there. To balance this 10 kilonewton, we have to apply another 10 kilonewton downwards at this junction. Because that junction also should be in equilibrium. So this 10 kilonewton balances this 10. In addition to that, he has given 20 kilonewton there. That also we have to take. So that means total force acting here is 30, 20 plus 10. And the reaction here will be, so naturally to balance this, to have the equilibrium of this first portion. So this is 30. So another 30 we have to take in the other end. So that means 30 acting downwards here. Naturally 30 kilonewton should act upwards here. So finally what you can say, this is very important step. If you do mistake here, these answers will be wrong. So P values you have to find out first correctly by taking individual portions of the bar. Now for the second portion of the bar, P force is 10 kilonewton tensile. See here, it is tensile. And for the first portion of the bar, P value is 30 kilonewton, that is also tensile, away from the bar. So both are tensile. That means tensile stress will develop in both the portions. Elongation takes place in both the portions. So these two forces, they try to pull. They try to pull the bar. So extension of the bar will take place in both the portions. So delta L1 is the extension here. Delta L2 is the extension in this portion. So to calculate the total deformation, so we have to use the same formula. So delta L is equal to delta L1 plus delta L2. Once again, delta L is calculated by PL by AE. So corresponding force value, length, area we have to take here. Now here area is different. So the diameter is different. Pi d square by 4. So for this second bar, area will be pi into 10 square by 4 millimeter square. For the first one, area will be pi into 20 square by 4. Okay. And P value for this is 10 kilonewton. P value for this is 30 kilonewton. So that kilonewton should be converted to newtons. So that's what has been done here. Delta L is equal to delta L1 plus delta L2. So delta L1 is P1 L1 divided by A1 into E. Here E is constant because both the bars are made of same material, plus P2 L2 by A2 into E. So for the first portion, total load is 30 kilonewton. So 30 into 10 power 3 in newtons into length is 200 mm. Length is 200 mm. L1 is 200 divided by A1 is pi into 20 square by 4 into E value 2.1 into 10 power 5. So you can directly substitute here, or you can calculate, you can write down the data, A1, A2, you can calculate, then you can substitute here. Plus, so in both the cases it is elongation only, because both the portions are subjected to tensile force only, it is elongation. So for the second portion of the bar, P is 10 kilonewton. So 10 into 10 power 3 into length of this portion is 200 mm divided by pi into d square by 4. So pi into 10 square by 4. Diameter of this is 10 mm into E value same 2.1 into 10 power 5. Now if you simplify this, delta 1 L1 you will get this, delta L2 you will get this. If you add, then you will get this total deformation in millimeters like this. So this is how we have to do. So first step is to separate the portions from the bar. So that composite bar should be converted to simple bars of uniform diameter here, of course. Find out the forces acting on each portion of the bar separately by considering the equilibrium of each bar. Then after this, if they ask you to find the stresses and strains, so what you have to do? So stressing the first bar, sigma 1. So sigma 1, that has not been done here, but if they ask, you have to do that. So only total elongation has been asked here. They can continue the same problem. Compute also the stresses and strains in each portion of the bar. So in the first bar, let us take sigma 1 as the stress in the first bar. So sigma 1 is given by P1 divided by A. So P1 is 30 kilonewton. So 30 into 10 power 3 divided by A means pi into 20 square by 4. So that is the stress in this, that is tensile stress positive. Whereas sigma 2 stress in the second one, that is also tensile because tensile force is acting. So 10 kilonewton is the force. So P2 by A. So P2 is 10. So 10 into 10 power 3 in newtons divided by area is pi into 10 square by 4. So if you simplify that, you will get the values of stresses. Both are tensile stresses in Newton per mm square. So Newton per mm square you are going to get. So that's why this kilonewton should be converted to newtons. So that is about stresses. Finding the strains. Once again, strain is calculated in two ways. One is strain is equal to delta L by L. That is one formula. Otherwise, strain is equal to stress divided by Young's modulus, sigma divided by E. So using any of those two formulae, you can find out the strain. So delta L1 is this. This is delta L1. 0.09094 is delta L1 divided by L1. L1 is 200 mm initial length. So this divided by 200 gives the value of epsilon 1. This divided by 200, the 200 mm is the length of the second portion also. So this is delta L2. So this divided by 200 gives the value of epsilon 2. So yes, epsilon 1 and epsilon 2. Or you can use another method. Strain is equal to stress divided by Young's modulus. That is epsilon 1 is equal to sigma 1 divided by E. So E value is this. Sigma 1 you have calculated by using that P1 by A formula. So sigma 1 by E gives the value of epsilon 1. Sigma 2 by E gives the value of epsilon 2. So like that you can calculate the stresses and strains. So there are two methods to calculate the strains. So this is about how to find the stresses and strains in composite bars which are interconnected. Now this is another important problem wherein you can see there is a hole made in this bar. So this bar has got a this is not clearly visible. Okay, 30 minus 10. Okay, this is 30 mm. Please make a note that this diameter is 30 mm. Whereas here this is 10 mm. This is 10. So this hole is made in this bar with a diameter of 10 mm. So that means it is a concentric hole, exactly a drill at the center of the cross section. So what happens here, I have shown here, from here to here, it is a solid circular section. From here to here, it is a hollow section like this. So in this hollow section, outer diameter is 30 mm, inner diameter is 10 mm. Whereas in the solid section, diameter is 30 mm. So this is 30 mm diameter. In that, a hole of the 10 mm diameter is drilled. And the lengths are like this. This length is 600 mm from here to here. From here to here, it is 400 mm. So please write down that sketch here. Then you will understand. This figure is not much clear here. So and it is subjected to a tensile force of 25 kilonewton. Please note that at both the ends, away from the bar, it has been shown. It is a tensile force of 25 kilonewton acting away from the bar. So the importance of this problem is there are two areas here. From here to here, for the first 600 mm length, diameter is 30 mm, whereas from the second, from 600 to 400, 1000 mm, that is for this length of 400 mm, it is the area is different here. It is a hollow sectional area because hole is drilled here. So we have to calculate the areas here and here separately. So from here to here area is different. From here to here cross sectional area is different. So from here to here, the area of the bar is pi d square by 4. Pi d square by 4. That is pi into 30 square by 4. That is the area in millimeter square. Whereas from here to here, the formula is different. For a cross-sectional area of a hollow circular bar will be pi by 4 into capital D square minus small d square. That is, capital D is the outer diameter, small d is the inner diameter. So what happens? Pi by 4 into 30 square minus 10 square. That's what I have used here. Okay, so areas will be different here. Length is 600 mm. Here length is 400 mm for this portion. Here the area is pi by 4 into 30 square. From here to here area is pi by 4 into 30 square minus 10 square. But he has given force value same. So both the portions of the bar, they are subjected to same force, 25 kilonewton tensile. That means both the portions are separate, are subjected to tensile stresses. So here, so from here to here is one portion, from here to here is another portion. So the first portion is solid circular section, second portion is hollow circular section. Now, if he has here, what happens is this is a separate type of problem. If the total elongation of the bar is 0.185 mm, here he has given the total elongation. So this portion that is elongation in this portion, that is delta L1, and elongation in this portion delta L2. So delta L1 plus delta L2 is 0.185 mm. That is given. So total delta L is given. Find out the value of Young's modulus. So Young's modulus value is unknown here, E value. So E value depends on the type of the material. So we have to use the same formula. So we know that total elongation delta L is given by, so PL by AE. So PL by AE is the formula. So delta L1 is nothing but delta L1 for this portion plus delta L2 for this portion. So for this portion, PL1 by A1E. So P by E I have taken common because it is same for both portions. P is 25 kilonewton, E value is unknown. So here E value is unknown here. So PL1 by A1E is the elongation in the first portion. PL2 by A2 is the elongation in the second portion. If you add them, so you will be getting total elongation or total deformation delta L. So just substitute whatever you know. So here P is known. See, from here E is unknown. If you bring that E to the LHS, this delta L comes to the denominator. So P by delta L. So delta L value is given here 0.185. So P is 25 kilonewton. So 25 into 10 power 3 divided by delta L is 0.185 into L1. L1 is 600 mm here, divided by A1 is area of this portion, solid circular portion, pi d square by 4, pi into 30 square by 4. 30 mm is the diameter. Plus L2 is the length of this portion from here to here, 400 mm, divided by area of that will be pi by 4 into 30 square minus 10 square. Okay, that is the area of the hollow circular section. So if you simplify this, you will get the value of E. So here you are getting the value of E as 2.007 into 10 power 5, or roughly 2 into 10 power 5 Newton per mm square. That means the material is steel only. It's a steel rod only, because we got the value of P as 2 into 10 power 5 approximately. So this is how we have to do. Okay. So why I have taken this problem is, here a hole is drilled. A hole is drilled in the bar. So we have to take the net area. Net area means when a hole is drilled, it is converted to a hollow section, maybe circular or rectangle, whatever it is. So corresponding area we have to find out. So very important, finding the areas, it is very important. Students do mistake there only. So for a solid circular bar, area is pi d square by 4. For a hollow circular bar, pi by 4 into d1 square minus d2 square, like that you can take, where d1 is the outer diameter, d2 is the inner diameter. So work out this problem once again, so then you will understand. Next, last problem I am going to explain here. So this is diagram given. There is a force P acting on this composite bar. Okay, so there are two portions here also. One is made of steel, another is made of aluminum. It is given here, and of course this is a square rod, not a circular one. Square rod of a square bar of area 5 by 5, that is 25 centimeters, and aluminum 10 by 10. So that means this area is 25 centimeters square. This area is 100 centimeters square. So once again, that centimeter square should be converted to millimeter square. That is very important. Huh? So newtons and millimeters, you keep that in mind. So in this case also, what he has done given is total contraction. Here it becomes contraction because P is a compressive force. So there are two bars here. P is acting like it is supported. It is on the ground, let us say. So P is acting downwards, means it's compressive. If P is given like this, then it is tensile, but it is acting downwards. It's a push force, compressive force. Now contraction takes place here, and this is actually how much is the length of this? This is 30 centimeters. This is 40 centimeters. Please write down the sketch clearly. So 30 centimeters is the first portion length. 40 centimeters is the second portion length. Area of first portion is 25 into 5, that is 25 centimeters square. Area of second portion, aluminium, is 10 into 10, that is 100 centimeters square. Now, once the materials are different, E values will be different. He has given the Young's modulus of steel as 2.1 into 10 power 5. That is, I have taken this as E1. Young's modulus of aluminum is slightly less than that of steel. See, it is one third of steel, 0.7 into 10 power 5. So that means steel is stronger than aluminum in compression and tension. That is the meaning. So 0.7 into 10 power 5 MPa is the value given for Young's modulus of aluminum. Now, same formula is used. Delta L is equal to PL1 by A1 E1. Here E1 E2 are different now, plus PL2 by A2 E2, because they are made of different materials. E values will be different. Now substitute. So here he has given the total contraction, that is delta L value is given as 0.25. So LHS is 0.25 is equal to P is unknown here. Find the force P. So P into, so P is common, you can take it outside. L1 is 300 here. That means 30 centimeter means 300 mm. Please note that everything linear measurement should be converted to millimeters. So 30 centimeter means it is 300 mm. 300 divided by Young's modulus of steel I have to take for the first portion, which is 2.1 into 10 power 5 into A1. So A1 is 25 square. Okay, so it should be 5 into 5, you know. That is 5 into 5 means you can convert this into millimeters, 50 mm by 50 mm. That's what I have done here. It's a square rod, so 50 square. So 50 by 50 is the area, plus for the second portion, for this one, P same value. So P I have taken outside. L2 is length of this one, 40 centimeter means 200 mm, divided by Young's modulus is different for that, E2, 0.7 into 10 power 5, that value you have to take, into area is 100 by 100. See, this is 100 square. So 10 centimeter means 100 mm. So 100 by 100, 100 square. Now if you simplify this, you will get the value of P in newtons. Please note that P you are going to get in newtons, because Young's modulus value is in Newton per mm square. MPa means Newton per mm square. Please make a note of that. So megapascal means Newton per mm square. So you will be getting the value of P after simplifying this in newtons. Convert that into kilonewton. Divide by 1000. So once that value of P is obtained, so divided by 1000, you are going to get it kilonewton. So in this problem, you are getting the value of actually P as 218.76 kilonewton. That means in newtons it will be into 10 cube. Okay. So convert that into kilonewton. So why I have taken different types of problems? See, just see the significance of each problem. So today, now I discussed, I think, four types of problems. So one is finding the reaction. This is the first problem I discussed. So it is restrained at both the ends. So they have asked to find the reactions. So for that, we have to assume one of the reactions has P, and using equilibrium equation, find out the other reaction in terms of that P. Then write down the free body diagram of individual portions separately and check what is the value of force acting on each bar separately. Apply the that delta L1, delta L2, delta L3 formula, that is PL by AE formula for each of the portions separately and add them, and the total deformation should be zero. Why it should be zero? Because it is restrained at both the ends. That is the condition. Even though each bar may have contraction or elongation, final deformation will be zero. That condition is very important that we have to use. Once you use that, you are going to get the value of P. Then once you know the value of P, you can find out the reactions. Once those forces are known, you can find out the elongations as well as the stresses and strains. That is one type of problem. Second type of problem, so I have taken two bars like this, Here, once again, procedure is same. We have to separate these two bars and find out the forces acting on these two bars. So when you are taking the equilibrium of each bar separately, take the last one, first and last one. Here only two are there. So this is subjected to a 10 kilonewton force downward. To keep that in equilibrium, there should be a force acting upwards, on downward, upward force. Then take out this upward bar. Here, this 10 is to balance this. Plus already 20 kilonewton is given here. That also we have to take. So totally it becomes 30 kilonewton. To keep this bar in equilibrium, they should act a 30 kilonewton upwards like this. That means finally, this bar is subject to a tensile force of 30. This bar is subject to a tensile force of 10. So correspondingly, use the formula and find out the total deformation. And you can also compute the stresses and strains using the respective formulae. Now in the third problem, I have taken a drill in the bar, hole in the bar, so that area is different. One is solid circular area, another one is hollow circular area. So formula remains same. Area formula PL by AE remains same, but area formula differs. So pi d square by 4 is the area for the solid portion from here to here for this 600 mm length. Pi by 4 into d1 square minus d2 square, that is outer diameter minus inner diameter square. So that is the area for this hollow. So other things remain the same. If they ask you to find stresses and all in this also, stresses and strains, you can just use the same formula. So P by A for the stress and sigma by E or delta L by L for the strains. Okay, those formula they will never change. Similarly, next in this problem also, compressive force is given here. So as usual, we have to, of course, they are made of different materials here. That is a change here, E1 and E2. So formula remains same here. So he has given the total contraction. P value he has asked. Suppose in the same problem, so P value may be given, delta L may be asked. Okay, so that is also possible. So anything is possible. So you can have one more force here. One more force. Here, let us say 10 kilonewton is applied. Here another 5 kilonewton is applied. Then what is the change in length, total elongation of the bar, like that. So varieties of problems we can solve. So when they give more than one force, then you should take the bars separately. Equilibrium of bars you have to take separately like this, and you have to compute the forces acting on each bar. Then apply the respective formula PL by AE. If it is a uniform rod bar, you can apply. If it's a tapering bar, then you have to apply the tapering bar formula. Okay, so this is about the finding the deformations in composite bars having two or more sections. So whatever, see, I think I have done some 10 to 12 problems in the last 3 classes. So I have explained you have to work the same problems. So I have sent you the notes. Write down these problems in your notebook And some steps I have not shown here that you have to calculate and you have to check the answers. Please check the answers, whether the answers are correct or not, you check it. So next class, I am going to explain what do you mean by deformation of a body to self-weight. So in the last previous problems, we have not considered the self-weight. So in that self-weight, you have got two types, that is a conical bar as well as cylindrical bar. You have got, so how to do problems on those things that we will discuss as a bar subjected to self-weight. So formula is different for that. So then some more problems we will do. I am going to explain. So all the steps are not given in these notes. So you have to work it out. You have to work on your own and check the answers So this is a lengthy chapter. First chapter is a very lengthy chapter. So, but very, very important. So whenever you want to analyze the strength of any material, so stresses and strains and modulus of elasticity, they are very, very important. They are the governing parameters in analyzing the strength of any material. So still I have not come to shear stress and shear strain. So whatever I am explaining now, it is only normal stress or direct stress, or in that two types are there, tensile stress and compressive stress, depending on the nature of the force. If the bar is subjected to tensile force, tensile stress will develop. If the bar is subjected to compressive force, compressive stress will be developed. And due to tensile stress, elongation of the bar takes place. Due to compressive stress, contraction of the bar takes place. Our usual assumption is elongation is positive, delta L is positive. If it is contraction, delta L is taken as negative. So these are the assumptions we are going to make in doing problems. Okay. So next class I am going to explain from this deformation of a bar due to its self-weight. So weight of the bar is also taken. So weight means density will come into picture. Center of gravity. At the center of gravity, weight will act. So that we will see in the next class. Okay. So if you have any doubt, you can ask me. So I have sent this PDF of this notes in the Google this thing only. You can download it and save it. Any doubt is there?
No, sir.
No. All of you are awake?
Yes, sir.
Huh?
Yes, sir.
Yes, sir. Yes. I thought you may be sleeping. Okay. Let me call the names. 19 batch. 002.
Yes, sir.
Yes. 003.
Yes, sir.
005. 005. Left off, huh? Darshan. Not there? I'll put him absent. 006.
Present, sir.
Deviation. 007.
Present,
Sir,
sir.
005 present.
005 present. Where were you?
Sir, network issue, sir.
Network issue. One simple reason all of you can give, network issue. Anyway, so 007, 010.
Present, sir.
Present,
Sir,
sir.
007.
No. 007, Johnavi. Yeah.
Yes, sir.
Then 011,
Present, sir. Preeti.
Preeti. Present. Okay. Then 13, Medhesh.
Present, sir.
You have not joined with college mail?
Sir, I joined
Nilesh?
with, sir, actually I joined
At
with the college.
jyotiit.ac.in. You have not joined in that.
No, sir, I've joined with college mail ID, but the first name and the last name I have changed. And I
You do it. You connect with that college this thing. All
Yes,
of
sir.
them are joined. Only if there is any problem, you please call Raghav sir. Okay,
Okay.
he will help you. You have his number?
Yes, sir.
Call him. He is the person who takes charge of all you people. So 13, 17, 17, Shreyas. Shreyas,
Present, sir.
yes.
Present, sir.
I want to check whether you are sleeping or awake. 18,
Present, sir.
Shreyas. 19,
Present, sir.
Shweta. Surya, 21.
Yes, sir.
Yes. Muzaffar, 15.
Present, sir. Present,
So
sir.
you have also not joined using college this thing, Only your name is displayed here. You please talk to Raghav sir, okay? He
Okay.
will make the arrangement. Okay. I think only this much are present. Okay. Then next class is on Monday. Okay. So I have done I have explained a lot of problems in the past 3-4 classes. So subject is, if you work, it will be easy. Okay. So derivations, 4-5 derivations, I have explained. Lot of problems. I think 10 to 12 problems I have explained. Fundamental concepts, definitions, everything I have explained. So you can download the textbooks also. It is there in the net. So you can download any book. Bhavikati book is available. R.K. Bansal is available. Just go to Google and type that strength of materials or mechanics of solids. That is another word used for strength of materials. So mechanics of solids, strength of materials. You can download the textbooks also. Soft copy you can have. And once the college starts, we will solve some more exercises because this numerical subject you have to work more. So more number of problems you solve, better you will be confident. Okay. Okay. I hope you don't have any doubts. So tomorrow, day after tomorrow, Saturday, Sunday, you just go through all the things whatever I have covered in the 4 classes. So 4 classes I have taken in SOM. So just glance all the things. I will continue on Monday. Okay. Have a nice day.
Thank you, sir.
Okay.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Okay. God bless you all.